These days, you can't escape time. It's everywhere. Clocks on your computer, your mobile phone, and on the dashboard of your car. Today, time can seem like a burden. But for our ancestors, it was the key to survival.
The fact that the sky had cycles we could predict is very important because it meant that we had some way to understand the larger reality around us.
Understanding that reality prompted one of humanity's greatest leaps forward. Using the stars to predict seasons helped people drop the nomadic ways of the hunter-gatherer and settle.
You can imagine two different tribes. One of them noticed that when certain stars were rising, that's when they could plant their crops, because that's when spring was coming. The other one doesn't know this. They don't look up, they don't notice the stars, they just do whatever they want. You know, which one of these is the more successful? Well, the ones who study the sky. They can feed their population, they can grow and become bigger, and then they study the stars even more.
The ancients celebrated that success with enormous monuments built to make incredibly careful observations of the sky. There are many of these sites around the world. Perhaps the most famous is Stonehenge.
When you're talking about ancient and prehistoric sites that might have something to do with astronomy, it is hard to avoid talking about Stonehenge.
Built on Salisbury Plain in the south of England, these circles of rough-hewn rock were built 4,500 years ago, in part to observe and chart the solstice.
The most obvious astronomical alignment is the summer solstice sunrise alignment over the heel stone at Stonehenge.
The solstices happen at 6-month intervals and mark a very important astronomical shift in the Earth's alignment in relation to the Sun.
Because our axis is inclined as we go around the sun, that means that sometimes parts of the Earth are actually tipped towards the sun and have a more direct sunlight hitting them. The summer solstice is when the northern pole is tipped as far as it's going to tip towards the sun, and we're getting the most direct sunlight possible. In the winter solstice, the opposite is true.
The solstices were the longest and shortest days of the year, and they marked important turning points when the seasons of summer and winter were at their midpoints.
It becomes then a reference point. It allows you to know where you've been and where you were going.
It's believed Stonehenge was used to measure these solstices. As the sun approached the solstice, it would track along the blocks until a beam of light illuminated the center. At the winter solstice, the sun sets between a pair of giant stone blocks directly above what's called the altar stone. During the summer solstice, the sun does the opposite and shines through the heel stone to illuminate the altar. Not only were the solstices indicators of the annual cycle between summer and winter, they also gave humanity the means to time the year.
The date of the solstice never changes because the Earth goes around the sun in a wonderfully closed orbit. It always comes back to the same place. So the summer solstice happens at the same time every year. That was something the ancient people could latch onto.
And virtually every one of them did it. Cultures all over the world built massive monuments to track the solstices. One fascinating example is Chaco Canyon, a stone city in the American Southwest, built more than 1,000 years ago by a mysterious people called the Anasazi.
Chaco Canyon is a place where a very sophisticated civilization existed that was able to develop monumental architecture and was able to celebrate some of the symmetries they saw in the universe. So this is Casa Rinconada.
That's amazing.
Beautiful?
Astronomer Brian Penpraise is here with his student because he believes that hidden within the geometry of these structures are clues that illustrate the deep connection these people had with the skies.
It's got almost this perfect symmetry. Those two entrances define an axis of symmetry, which is aligned almost perfectly with north-south. Plus, there's an additional alignment with this window over here and the summer solstice sunrise, which will light up one of those niches as it enters in through the window.
As a cultural touchstone, today we take the sun for granted. But what's clear from archaeological records is that our ancestors did not. In those celestial rhythms, they saw evidence of some otherworldly power.
I think they saw in the enormity and the beauty and the clockwork of the universe something beyond themselves, indeed something spiritual. And so I think notions of great gods and notions of the size and the behavior of the universe probably were quite closely linked.
Cultures and civilizations all over the world saw the same things in the sky and developed similar mythologies to explain them. The Inca, the Mayans, the Babylonians, and other ancient cultures saw the skies as a divine realm populated by the gods that ruled over Earth.
They all worshipped the night sky. They built enormous structures. People bowed down to the grandeur of the cosmos in the form of these architectural wonders that were designed to pay homage to the night sky and its denizens.
Nowhere is this more evident than in Egypt's Great Pyramid.
There are interesting architectural details to the pyramids, and in particular the Great Pyramid, the largest pyramid and probably the very best built.
4,600 years after it was built, the Great Pyramid remains one of the largest buildings on Earth. As big as 7 city blocks and rising to around 150 meters, it was built as a tomb for the pharaoh Khufu.
An interesting astronomy has been attributed to the Great Pyramid, which has some unusual architectural elements that you don't find in all of the pyramids.
These ancient engineers who built this pyramid were able to arrange 2.3 million stone blocks, each weighing about 2.5 tons, with an incredible level of precision. They aligned this enormous structure so that each side faces one of the cardinal directions: north, south, east, and west. But what fascinated researchers is what was on the inside.
There are 2 shafts that just drive through these block walls of the Great Pyramid, one to the north and one to the south. Those 2 shafts point to 2 celestial destinations.
Or at least they used to. Today, these shafts don't line up neatly with any stars. But nearly 5,000 years ago, they did.
The shaft lines up where the North Star would have been and where the center star of Orion's belt would have been a long, long time ago.
It's believed the shaft to the north aligned with the star that would have been the North Star thousands of years ago, and the shaft to the south with another star in the constellation Orion. That's not the case today, because Earth goes through a cycle where the tilt of its axis changes.
There was no North Star because of the precession of the Earth's axis, which takes place over a timescale of 23,000 years. We believe what they did is use one star from the Big Dipper and one star from the Little Dipper, which if you drew a straight line between them, contained the point in the sky about which all the stars rotated, and aligned the pyramids with that.
That point was the star Thuban, which the Egyptians associated with rebirth. All those thousands of years ago, it would have been Earth's pole star. If that's where the northern shaft pointed, then the southern would have been aligned with the star in Orion's belt that the Egyptians linked to Osiris, the god of resurrection. Even more important to science, by applying what we know of the 23,000-year progression, we can run the clock backwards and discover exactly when the Great Pyramid was built.
We can use modern astronomical calculations to find out when those 2 stars were aligned with the North Pole, and the result is that the pyramids must have been designed around 2467 BC.
It's kind of lovely to think how the human race decided that the stars were so important. They're just little lights in the sky. Yeah, they change position, there are cycles to them. But we built our largest monuments, things like Stonehenge, the pyramids. They're aligned to the stars, they're related to them. So somehow these faraway little lights took on cosmic importance.
Stonehenge and the Great Pyramid. These enormous structures are a testament to how important the skies were to early civilizations. But some believe these structures were too big and too precise to have been built by such primitive people. Could they have had a little help from visitors from the sky? Once our ancestors settled, their fascination with the skies went into overdrive. They built massive structures to make extremely detailed observations. But the question is, why? Why did the ancients construct such huge buildings to observe the skies when they didn't have to?
It's hard for me to understand why you build a gigantic monument out of stones. That's the hard way to do it. And I don't think you get budgets for astronomy to build things bigger than you need to do.
All sorts of mysteries surround the construction of these monuments and why they were built. Some theories suggest that instead of just observing the skies, they might have been erected using knowledge from visitors from another world. That's the idea behind the ancient astronaut theory.
The ancient astronaut theory tries to establish whether or not extraterrestrials visited Earth in the remote past.
Why do we think it's even remotely possible that people of prehistory were visited by aliens? Because ancient texts from cultures around the world speak of mysterious beings cruising the skies in chariots of fire and bringing humanity wisdom from the cosmos.
The Mahabharata, an ancient Indian epic, which is their equivalent of the Bible, is packed with stories of gods which a long, long time ago flew around in marvelous golden sky ships referred to as Vimanas. They were also very specific in mentioning that they are machines made out of metal. It describes their weaponry, that some Vimanas had the capability of cloaking themselves to become invisible. All crazy science fiction type stuff. But was it really science fiction? That's the big question.